Real-world computer programming for kids, Step 32. Using Visual Studio's built-in tools to painlessly improve our code. As was foreshadowed in the last episode or step, this time we are going to use some tools Visual Studio provides to potentially improve our code. If you take a look at the menu items beneath both the Debug and the Analyze main menu items, you will see that there are several interesting tools that Visual Studio makes available to us. Just to name three of these, there are Debug, Performance Profiler, Analyze Code Cleanup, and Analyze Run Code Analysis. For now, at least, we will focus on the two mentioned tools from the Analyze menu. Code Cleanup. Select Analyze Code Cleanup. Configure Code Cleanup, as shown here, and it shows a screenshot in the newsletter. That will invoke, that's the programming term for show, display, bring up, etc., the Configure Code Cleanup dialog. You will see that there are two profiles. One is slightly more intrusive or helpful than the other, depending on your point of view. And it shows the screenshot of that. Select Profile 1. It will help us to keep our code as private as possible, clean up our using clauses by removing those that we don't need to have, meaning none of the code we've written is using the code that those using clauses are referencing, and also alphabetize the using clauses so that it's easier to find what we're looking for there. Notice that there are also many other things you can have the Code Cleanup tool do. They can be seen in the Available Fixtures list at the bottom of the dialog. Most of these we don't need to worry about. They are for more advanced coding situations. There are two, though, that we should move from the bottom, Available Fixtures, to the top, Included Fixtures, namely Remove Unnecessary Casts and Remove Unused Variables. Note that they are selected in the screenshot below, and of course, it shows a screenshot. Once you select them, click the up arrow button, rectangled in the screenshot above, to move those two fixtures from the Available to the Included list. Your Configure Code Cleanup dialog should now look like this, and it shows a screenshot of what it should look like. Why did we do this? Why did we move those two additional fixtures up to the top? Well, I'll tell you. If we have unnecessary casts, we are using up computing resources unnecessarily. Not a big deal for our app being so small, but it's a good habit to get into. By casts, what is meant is not the thing you get on your arm when you fall out of a tree, but code like this. And it shows an example from our code of a cast that takes place. The return value of the call to math.round is being cast or typecast to an int by means of that left paren, int, right paren part. It could actually be that the cast is not needed, as you would assume that a rounding operation would, by its very nature, return an int. We'll see if it gets changed. The reason for removing unused variables is probably more obvious. If you declare a variable and it's not used anywhere, nothing is ever assigned to it or read from it, why does it exist? It won't cause a huge problem for the compiler. It will just look at it real quick, see that it's not used, and ignore it. But it could confuse us. If we see it hanging around, so to speak, we may assume it actually does something when it doesn't. And by real quick, I mean as fast as the speed of light, which is about 300 million miles per second. 299,792,458 miles per second to be exact. Well, maybe not quite that fast, but a lot faster than the speed of sound, 1,125 feet per second anyway. Now that we have it configured the way we want it, select Analyze Code Cleanup, Run Code Cleanup Profiler 1 on Solution, and it shows a screenshot of that. You probably just saw a dialog come up, a green flash travel across it, and then it closed again. Not really a dialog, but a form that dismissed itself when it was through. It probably worked so fast that you barely saw a blip on the screen. That was my experience anyway. And the int cast is not removed or complained about, so it is needed. Visual Studio does actually tell us, though, even without running this tool, if we have unused variables. It informs us by graying out the unnecessary variable or variables. So it works on our code on the fly, always examining what we are doing, what we are coding, and making suggestions if what we're doing seems off to the compiler. Look at this at the top of the main form1.cs form, the only form actually in our project, and it shows a screenshot of that. Notice how original question in of in is grayed out. Why? Right-clicking it and selecting Find All References, there is a place where it is assigned to, and that code is shown below, and the line that that variable is assigned to is italicized. So why is Visual Studio graying it out, telling us it is unused? It is assigned a value right there. So it is used, right? Actually wrong. Visual Studio is right. That value is never used after that. It is not accessed anywhere else. It's being assigned a value for no reason. It's as if we were telling the original question in of in variable, remember this value, but then never asking for it again. Why does it need to remember it? It doesn't. It's like your parents telling you to remember that they put the motorhome in the refrigerator and then never asking you where the motorhome is. So then, removing the declaration of the variable and the line above where it is assigned to will make the code cleaner and clearer. No more grayed out variables. We can see then that Visual Studio's built-in intelligence has come to our aid again. Code analysis. Now let's select Analyze, Run Code Analysis on Solution. It also runs very fast and reports at the bottom of the screen, no issues found. It ran fast because ours is a small project and computers work very fast. That's the main advantage over humans. The code analysis found no issues because the greatest programmer in the world was on the case. Not. It found no issues basically for the same reason it ran so fast. There wasn't a whole lot to take issue with. It's a small, relatively simple project. Performance Profiler. Now let's try Debug Performance Profiler. The Configuration Manager dialog is invoked, and a screenshot is shown of that. Note that it's advising us to change our app from debug mode to release mode. And the screenshot is shown of that. What this means is that an app starts off in debug mode as it's in development. Once you're ready to release or deploy it, you change it so that it can be released or deployed. So let's do that. Click the Change Target button just above the warning message. Select Build, Configuration Manager, and the Configuration Manager dialog is invoked. And it shows that in the screenshot. As you can see, unless somebody changed it already, the app is currently set to debug configuration. From the Active Solution Configuration dropdown, select Release and Wallaby, as the Walloons say. Or is it the Australians? I forget now. This is how it should look now, and another screenshot is shown. Close the Configuration Manager dialog and go back to the tab that was created when we selected Debug Performance Profiler. Its tab says something like Report 20200824-1450.diag session. You might be tempted to think these are random numbers, but they are not. It's basically identifying itself as being a diagnostics session report that was initiated on 2020-824. In other words, August 24th, 2020, at 14:50, 2:50 p.m. The warning label has disappeared. It's been watching you like a hawk to see if you would change the configuration from debug to release, and when you did, it pulled the plug on the warning message. And it shows a picture of a hawk watching you. And the caption is Photo of Savannah Hawk by Charles J. Sharp. Notice the guy who took the photo of the hawk watching you was not Charles Schwab, who invented cotton balls, but Charles Sharp, which is a fitting surname for a wielder of the photographic apparatus. Now we can select the options that make sense for us in the main area on the Diag Session tab. We may as well, out of curiosity at least, select all of them, but the first one. The first one is taboo, or at least unnecessary, because we have no calls to async or await in our code. This is an advanced topic that we will avoid, at least for now. When you check most of the checkboxes, you will see that doing so makes all the others unavailable, with the exception of CPU usage and event viewer, which can be run simultaneously. All of the options must be run by themselves, not in tandem with any of the others. So even eschewing the first option, .NET Async, we will have to run the app 4 times to use all of these options. So we'll do that. Run 1 will be CPU usage and event viewer. Run 2, .NET object allocation tracking. And run 3, memory usage. So select the first two listed above, CPU usage and event viewer, and then click the Start button. Our app starts up. Open one of the CSV files and answer all its questions. I recommend that you open the same file each time for consistency's sake. Note that last word is pronounced with a long A and is one syllable. It is not pronounced sake, which is a Japanese beverage made out of old dirty socks, and has nothing to do with the matter at hand. I'm using the file that I named The Rain in Spain Falls Mainly on the Sheep.csv. When you go through all of the questions, exit the app via the close box, the X in the upper right corner of the app's main and only form. Visual Studio will build a fancy report for you, something like this, and it shows a screenshot of that report. The top 5 categories pie chart, comprised of a rather odd but delicious-looking amalgamation of gooseberry pie, mainly, strawberry, rhubarb, lemon, raspberry, and blueberry, is quite interesting. Based on the kernel taking up most of the resources, it's safe to say that a can of corn must have gotten lodged in our computer somewhere, bogging down the works. The other interesting thing to me is the time the pack of robotic gerbils were on their wheels turning out this report, 40.096 seconds. You can see that in the upper left. I'll see if I can run the app in about the same amount of time the next couple of go-rounds too. And then it shows a screenshot of some gerbils, baby gerbils. Next up, the Instrumentation Test. You can close this DAG session tab just used. When you do, you will be given the option to save it. You can if you want to. You might as well. The pie chart itself is suitable for framing. You can win friends and influence people by propounding on the depth and scope of your knowledge regarding these pie pieces. Open a new DAG session by selecting Debug Performance Profiler anew. Deselect the previous two selections and check the .NET Object Allocation Tracking checkbox, and then the Start button. This time I made it through the questions in 34.298 seconds. And it shows a screenshot of that, proving that. As you can see at the bottom left, there is a ton of arcane and geeky information that you can delve into if you're so inclined. Speaking of inclines, notice the amateur skateboarding ramp at the top, and below that, a nice view of a city skyline, with the city center at the far left, receding gradually into the outskirts of town and then the boonies further on. Next, and finally, we will run a test on memory usage following the same process as before. Debug Performance Profiler, deselect the checkbox, check memory usage, and then click the Start button. Do you think I can break my international speed record again? This time it takes 32.238 seconds. I am the champion. But then again, I just got slapped by the spinning gerbils. Look at this message. And it shows a message that we forgot something. What? I didn't notice the Take Snapshot button. I guess I was too focused on beating my old time record. Okay, I'll try it again, and this time try to emulate the hawk's amazing powers of concentration and watchfulness. This time, watching like the proverbial hawk, or that Savannah hawk we saw earlier. I saw the Take Snapshot thingy, and there's a screenshot of that. But the dadburn thing slowed me down, and it took me 50.475 seconds to complete the 11 questions. A travesty. Oh well. I took 2 snapshots, and there's a screenshot of those. You can see here that in the 17 seconds between the first baseline snapshot and the second, memory usage and object usage both went down. What does that mean for us? Not much. Why did the usage go down? I don't know. That would take a much deeper dive into the process, no pun intended. This step gave you an introduction into cleaning up, analyzing, and profiling the performance of your code. Not all of it is overly applicable to you at this stage of the game, but it gives you a peek into some things you might want to explore in the future. Feel free to experiment with these tools. In the next step, we will pretty much wrap up our discussion of this app before moving on to databases, which I consider to be a pretty fascinating topic and extremely useful technology. We will use a code comparison tool to see how our code has changed from sometime in the past to the most recent code. I'll show you how to do that, why to do that, and what you must do in advance to prepare yourself to be able to do that. Don't worry, it's not hard. Kind of fun, really, and less arcane and mysterious than this step was. Until then,